Right, welcome to a data presentation. I'm just going to briefly go over some MEI notes. And what we'll look at in this video is bar charts, pie charts and vertical line graphs. We'll also look at histograms and shapes of distributions of data. So categorical data, rather than quantitative sort of data, is best measured using, presented rather, using pie charts or bar charts. So here you have, for example, the level of pain, non, mild, moderate and acute, and the number of times this occurs. And over here we've got a bar chart and then a pie chart. We know the total angle equals 360 degrees around this pie chart. So if we want to work out the angle of, say, mild, we can simply work out the percentage of mild people and times it by 360 degrees. Notice the bar chart compares the frequencies, and you can easily read this off. So you have the frequencies here, whereas the pie chart compares proportions. Right, if you have two sets of data, you can compare them side by side on a bar chart, or side by side on two separate pie charts. We can also use vertical line charts to compare data, and we simply draw a line against frequency. So discrete data is a good way of presenting discrete data, in addition to using a pie chart or bar chart. Right, histograms is really important, and when we've got discrete data, we can use line graphs, bar charts or pie charts for categorical data and discrete data. However, when we've got continuous data, then a histogram will be more suitable. Now notice here, firstly it ends on 45 and begins including 45 to 50, and then M including 50 all the way to 55. Sometimes that's not the case, and we'll talk about that in certain examples, so that's something to keep in mind. And the class width is it's constant throughout, and sometimes the class width isn't constant, in which case we need to work out the frequency density. So we've got frequency over here for each case, and if we were to plot this, we'd get a histogram which looks like this. Okay. Another way of classifying eggs is in the following. So this time they've rearranged it from extra small all the way to large. The class intervals now are different. Okay, so here you've got 2, over here you've got 4 and 7, so forth, and then a frequency of 1. Right, given the class widths are different, if we were to plot this, this is what we'd get. And this clearly shows that this is actually incorrect. Well, it's not a useful diagram because it gives us the impression that the data is negatively skewed. We just saw in a previous histogram that in fact it was distributed side by side equally around the central model group. And so the way we'll get around this when we've got different frequency intervals is to in fact calculate the frequency density, and by doing that the area of each bar will be proportional to the frequency. So here's our data again, here's the class widths, and what we'll do is divide the frequency by the class width to get frequency density for each one. And then we can now plot our frequency density against the class width. If we were to plot that frequency density against class width, this is what we now get. And the area of each bar gives us the frequency, since we now have class width divide frequency times frequency density is the area, which is the frequency. Bear in mind that on the y-axis we don't have frequency but rather frequency density, so when you're labeling this, please do make sure you write frequency density and give your bar chart, histogram, a title. Let's look at an example here. Here we have our class width, the widths given to us and the frequency associated with each one. Right, if we were to plot the data, this is what we would get. As you can see, the weight has been put in a slightly different form. If we were given this form in the first place, then the class width will be taken from halfway between the two intervals. So it's 34, 35, halfway is 34.5, and it goes up by 0.5, so it go down by 0.5. And so it will be from 29.5 to 34.5, and that gives us a class width of 5. And then we simply do frequency over class width to give our frequency density. If we were to plot that, please remember to put down either the frequency in terms of kilograms in this case, or frequency density against the units of your intervals. Now, another important concept is the idea of distribution of data. Naturally, when it's symmetrical, so there's an equal distribution on either side, we say the data is symmetrical. When it leans towards the left, we say it's positively skewed. Okay, and when it leans towards the right, so you have greater amounts of data clustered around a higher value, then we say it's negatively skewed. Here you can see an example of something which is positively skewed and then negatively skewed. Right, just to highlight some common errors, it's important not to confuse a histogram with a bar chart. With a histogram, the area of the bar and not its height is proportional to the actual frequency. So the height is given by frequency density. The width, if we multiply the frequency by the width, which gives us the area, we get frequency. Another few points is that there shouldn't be any gaps between the bars. The horizontal axis should be drawn with a linear scale, and the vertical axis should show frequency density. Let's look at an example here. We have some intervals which goes 30, 34, etc. The class intervals, the boundaries are in fact 29.5 to 34.5. Okay, and here are the frequencies. So over here, here's something which is obviously incorrect. Firstly, there are gaps, and there shouldn't be, and we've got frequency on the vertical axis, on the y-axis. Right, this example here is still wrong, because the frequency density is worked out using the wrong class widths. It should go from 29.5 to 34.5. Instead, it's gone from 30 to 35. 30 to 34 or 35. We can tell this is in fact incorrect simply by looking at the value of the frequency density for each interval. So for the first one it's 0.5 and for the second one is 1.5. This is the correct version, where we have our widths and we have the class widths given to us and the frequency in between, and we work out the frequency by doing frequency divided by class width. As we can see, the frequency interval for the first one is 0.4, unlike the example that we just saw earlier, where the first one is 0.5 and the second one is 1.2, which are different values to the example we just saw earlier.